Alright, so we're going to start with the second part of the review here today, and we're going to start with number 23 is where we left off. So a sample data set is a bell-shaped distribution with a mean of 15 and a standard deviation of 4. What proportion of this data lies between the intervals of 11 and 19? So again, with that, starting out with a bell-shaped curve, I already gave us that data value. Dealing with a bell-shaped curve, right? And we have the normal distribution because we have mean of 15 and 4. So with this one, it's saying it wants us to know the intervals between 11 and 19. So our mean is at 15. And let's do this by just taking our intervals for our standard deviation. So let's see what we got. If we add 4, that's going to give us 19. And if we subtract 4, that's going to give us 11. So this, again, if we look at the z-scores, as far as saying 1, oh goodness, positive 1 here, positive 1 and minus 1. So that's 1 standard deviation away from the mean in either direction. And with those data values that I told you to kind of put in your head there, remember, right? 68% of the data lies between 1 standard deviation of the mean. So we know that 11 and 19 are 1 standard deviation, so it's approximately, you can just say 68%. Okay, so then it wants us to know the proportion of data lies between the rules of 7 and 23. Well, if we did that again and we know that our data values, I'm just going to label this, I'm just labeling it so we know where I'm getting these numbers from, 15 and 4. So again, your mean is at 15. And we know that 1 standard deviation is 19 above, and then 1 standard deviation below is 11. And then if we add 4 more, what's that going to give us? This is going to give us up to 23. And that's going to get us down to 7, right? So now we're looking at 2 standard deviations away. We're looking at a plus 2 standard deviations this way. Looking at a minus 2 this way. So the data between there is 95%. So the answer to this one is approximately 95%. And that's what we're looking at for those. Again, you got to remember the 68, 95, 99.7 rule. So number 25 then is going to construct a sample space that describes rolling a regular 6-sided die. So with this, a sample space, in other words, it's saying what data would you get if you rolled a 6-sided die. And all we're really looking at getting is the values on that die, right? So 1, 2, a 3, you could roll and get a 4, a 5, or a 6. That's all it's asking for. In other words, what data can you get from a 6-sided die? You can get any one of those values from just rolling it once, okay? What is the probability that a number less than 3 is rolled? Well, if you're just rolling one die and less than 3, right? So in other words, you could take, with this one you're looking at less than 3, you're looking at, you could get a 2, so you could roll a number 2, or, sorry, it's a bad number sign, or a 1. So you have 2 options you could roll out of 6 overall. So your probability is 2 over 6, which we can reduce that fraction, is 1/3. Alright, so 1/3. You have a 1/3 probability of getting a number that is less than 3 when you roll that die. Because when you roll a 6-sided die, you can either get a 1 or a 2 that would be less than number 3. And those are 2 options out of the 6 you have on that die. So now we're looking at 2 normal-sided dice are thrown. What is the complement to the event that the sum of the dice is greater than 4? So the complement to the event that the sum of the dice is greater than 4. So on this one, you're looking at what is less than 4. So in other words, you could roll a number 1 and a 1. You could roll a 1 and a 2. You could roll a 1 and a 3. That would give you 4, okay? And what are the options you could roll? You could also roll a number 2 on the first die and then a 1. You could also roll a 2 with another 2. And the last option you would have on this, right, if you rolled a 3 on that first die, you can only roll a 1 on the other die to see a number that is less than 4. For the sum, I'm sorry, of those numbers would be less than 4. So in other words, you would roll either 2 1s, a 1 and a 2, 1 and 3, and so forth. So those are just talking about the options you get. So a complement, in other words, complement is meaning the opposite of what it's talking about there. So instead of greater than 4, a complement would be less than 4. So if you roll any of those combinations on the 2 die, therefore you would get less than 4, or equal to 4. Now it's asking number 20, what is the probability that the sum is greater than 4? Well, for the sum to be greater than 4, you can kind of look at this, right? Think about this. The probability. Overall, you guys should realize you have 6 chances on each one of those, and if you multiply them by each other, you should be able to get 36 overall, because you have 2 6-sided die. Well, you can also make out a little table if you really didn't want to think about doing this. Okay. In fact, let me write this over here. Alright, so if you're going to make out this little table here for the 6-sided die, right, if you had 6 on one and 6 on the other, and you add those 2 values together, it gives you all the sums there for you. So therefore, we can actually see which ones are greater than 4. But together, we can see that we all have 36 total. So if we have 36 total, we know it's over 36. And we can just count. Hold on, I gotta write 6 instead of a 4. So over 36, we just need to count how many are greater than. So we just need to count how many are over number 4. In which case, you can do it pretty easily, right? So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 31 looks like. Alright, so we should have, in this case, to count how many that are greater than 4, let's count how many are 4 or less. 1, 2, 3, 4, 5, 6. So we got 6 that are 30 or less. So we should say we have 30 overall. And 30 over 36 can be reduced to 5 over 6. So the probability that the sum is greater than 4 is 5 over 6. Now, if we were looking at this next problem, it says a fair coin is tossed in the air 2 times. Find the intersection that H, a head toss, is first, and T, a tail, is tossed last. All that is looking for that in the setup, we're going to go over this too much, but with these, you talk about saying intersection is H for your heads and T for your tails. Just listening what it said, right? As far as getting a heads first and a tails last. And you flipped it twice. So what is the probability that a heads is tossed first and a tails is tossed last? So hopefully you realize flipping a coin, you have a 50% chance of getting a heads or a 50% chance of getting tails. So that's 1/2, right? Probability of getting heads or tails. Well, if you took 1/2 for your first flip, and then you have the probability of getting a tails on the second one, so you have 1/2 times 1/2, you should get 1 over 4. Number 31, we're looking at saying we have a 6-sided die is rolled. So find the union of the events E, the number rolled is even, and T, the number rolled is 3. So with that, what we're looking at, the union of it for the number rolled is even. So we know we want a 2, a 4, and a 6, right? A 6-sided die. Then we can also roll a 3. That's all it's looking for. In other words, you're saying you got these numbers that could be rolled for the union. So what is the probability that an even number is rolled or the number 3 is rolled? So the probability of even or the number 3. Well, we just did that. We just got that there are 4 probabilities. If you roll one die, then you can actually get a 2, a 3, a 4, or a 6. That's 4 options out of a 6, right? So you can get a 4 options out of 6, which can be reduced down to 2/3. Alright, so now on this one, let's look at this next one. So number 33, what's the probability that both marbles are blue? So it says there are 10 marbles in a bag, 7 marbles are red, 3 are blue, and 2 marbles are drawn without replacement. That is key, without replacement. So the probability that both marbles are blue. Well, to get a marble that's blue in the first draw, you have a 3 out of 10 chance. And to draw a second one, right, now without replacement, so there's only 9 marbles in there. And if we drew 1 blue one to begin with, we only have 2 blue left. So you're taking 3 over 10 times 2 over 9. And if you do that, so we get, let's use Desmos calculator, since we'll be using that, most of you guys will be using that anyway. So let's say we got, we got 3 divided by 10. Lower our button a little bit. And then we're going to say we got multiplied times 2 divided by 9. And should get 0.0666, which is the same thing as saying 1/15, I believe. Let's see what all this in this fraction here. Let's put this in a fraction for it. I don't know if it'll let us do that. But you can simply put this. Let's put this number here. We'll put 0.067. Alright, so what is the probability that at least one marble is blue? So that phrase, at least one marble is blue. So that should bring up that whole probability equation that is saying 1 minus the probability of none. Okay, so we can do 1 minus probability of none. And that is going to equal, we got 1 minus, now the probability of none in this case, we're drawing 2. So our first, to get none, of course there's 7 red marbles. So the probability of drawing that is 7 over 10. Now if we still don't want to draw a blue marble, we would like to draw another red one, right? Well, what is the probability of drawing a red one now since we draw one out without replacement? Well, now we've only got 6 red left out of a total of 9. Let's see what that gives us. Alright, so let's go here. Let's do, we got, parentheses first. I need 1 minus, and then in parentheses, let's take 7 divided by 10. times 6 divided by 9. And we should get 0.53. So let's go 0.53. 0.53. So now we're looking at what is the probability that exactly one marble is blue. Exactly one marble is blue. Well, we need to take 3 over 10 to find one blue marble. So we have 3 over 10 are blue. And then out of the rest, then we have the simple fact of saying that we have, on this one, we have 7 other marbles, right? That we, exactly 1 is blue. And so we had 7 over 9, because we have 9 marbles left in there because we took 1 blue out. And then that should give us, let's check that out. So we're going to take divided by 10. And we're going to multiply that by 7 divided by 9. And we should get 0.23. So 0.23. Okay, so classify the following as either discrete or continuous and identify the possible values. So with that, we're looking at the distance the car travels in a day. Well, it should be, you don't just jump from one spot to another in a car, it's pretty continuous, right? It's pretty continuous because the inches, feet, miles continually add up as you're driving, so it's continuous. And if you're going to drive in a day, you're going to go from zero, or I should say, you can say from 0 is equal to whatever x value you get, which is less or equal to infinity, right? Positive infinity. So therefore, you can go anything from where it starts to infinity, wherever it ends, right? So then we're looking at the sum of the numbers when 2 dice are rolled. So if 2 dice are rolled, the sum of the numbers, well, there's going to be gaps because it's going to be, when you roll those dice, you're not going to get the same numbers in consecutive order and keep it rolling, right? So it's going to be discrete. It's going to be discrete. Alright, and so the numbers you get when 2 dice are rolled, when you sum them up, you get anything from a 2. And then after 2, then you would get, you could add it up to where you got a 3 if you roll a 2 and a 1. You got a 4, 5. You get everything up to a 12, right? You can just list them all out to 12. So it would all add up depending upon the roll you get. In the mix you got, you should get all the way up to a 12. You got 2 6-sided die. So again, I'll just put a little brackets here saying that's those guys. Alright. Alright, so that gets us around 20 minutes of lesson, so we'll stop right there for this lesson, and I'll see you next time.